Hello everyone and welcome to our channel CodeChef. Today we'll be solving the problem add a bit with the difficulty level of cakewalk. Let's get started. Here in this problem statement is given that Loki was working with binary strings and he encountered an interesting problem. In Loki's world, binary strings are stored in reverse. That is, the least significant bit is stored as the first character of the string. The next significant bit is stored in the second character, so on till the most significant bit is stored in the last character. What does this mean? Normally, if I ask you to represent the decimal number 10, you'll represent it in binary as 100, right? But how Loki will store it is basically in the reverse order, like 001. That's all it is. Now, why Loki stores it like this? Because if you look at this number, the most significant bit is here and the least significant bit is here. So how Loki stores it is that the least significant bit is stored as the first character and so on till the most significant bit is stored in the last character. It just means that he represents the binary strings or numbers in reverse. Now, if I give you the normal binary string 100 and ask you how Loki represents it, what will it be? Please pause the video and try it out. Loki will just store it in reverse. So if I read this string in reverse, it is nothing but 011 and this is how Loki stores it. That's it. Let n be the number of bits in the binary string. Loki is going to add 1 to this binary string and we need to find the number of bits among the n bits of the string which change their state. And now this is the important criteria that if the result of the binary string increases the number of bits, the newly formed bits are discarded. Now let's look at some sample cases for clarity. There are t equal to 3 sample cases and let's look at each of them one by one. First we look at this. You know that Loki has presented you with a reverse binary string. Now in order to get the original binary string, what you need to do is you need to reverse this. But reverse of 0 is just 0. And then you're going to add 1 as the question states and you're going to see what the result is. The result is just 1. Originally you had 0 and you got 1. Now how many bits have changed? You only had 1 bit that was 0 and this has basically changed to 1. That's why due to the 1 bit change, you're getting the output as 1 for this test case. Let's look at this test case. You are presented with a reverse binary string. So in order to get the original binary string, you need to reverse this. Reverse of 100 is nothing but 001. Then you're going to add 1 like the question states and you're going to check what the answer is. Now the answer is 1 plus 1 is 0 with a carry of 1. 0 plus 1 is 1 and 0 stays it is. So now what happens is this basically is 1 and it changed to 0. This basically is 0 and it changed to 1. This 0 stayed 0. So due to the 2-bit change between the original what you had and the answer, your output is 2. Now here is the most interesting case. Let's check this. You have 1 1, right? And you're adding 1. Now why do I say 1 1 just as it is? Because reverse of 1 1 is also 1 1. This is the original string. Plus 1. Now when you do 1 plus 1, you get 0 with a carry of 1. Now you do 1 plus 1, you get 0 and a carry of 1. Now some people might say the output is 3 because this 1 changed to 0, this 1 changed to 0 and what you had here was 0 and it changed to 1. But remember the question explicitly said that if you get additional bits as a result of your addition, you need to ignore that. This 1 that you got here was a result of this addition, was an additional bit because you had 2 bits here and then your output had 3 bits. So you need to ignore this bit and then you need to check. This 1 basically changed to 0. This 1 changed to 0. So 2 bits have changed. That's why the output is 2. Because you're going to ignore the additional bits that came as a result of the addition. Now let's look at the approach to solve this problem. We know that Loki has given us with the reverse representation of the binary string. Basically that is, let's say that he has given us a string like 1011. Till now how we've been solving the problem is we take the reverse of the reverse string. We take reverse of the reverse string in order to get the original string, which in this case will be nothing but the reverse of this, that is 1101. Then to the original string we add 1 and then we simulate the process essentially. 1 plus 1 is 0 and then a carry of 1. 1 plus 0 is 1 and then these two ones just are 1s. So now you check how many bits differ. These two ones remain these two ones. However, this 0 and this one changed to 1 and 0. So 2 bits have changed between the original string and the answer that you get resultant after addition. So you output the answer to be 2. But is there a way we don't have to do this whole process but yet we can get the answer? We just want to process the string that Loki has given us. This string we want to process somehow and get the answer. And there is a way. For that we must understand one essential fact that when we encounter a 0, this 0 cannot propagate a carry to the left bits here. And why is that the case? Because See here, in this case also 1 plus 1 was 0, and so a carry of 1 came here. But this bit is 0 here. Since this bit is 0 here, 0 plus 1 in the worst case is going to be 1. You cannot propagate a carry to the left side as long as you encounter a 0 here, which essentially means that all the bits to the left of the encountered 0 will remain the exact same. They will not contribute anything to the answer. That is the main thing we need to note. That's why what we're going to do is we are going to process this. Remember, the string that Loki has given us, even though it's in the reverse order, that is good for us because it starts at the LSB and ends at the MSB. And even when you're doing addition, we start at the LSB and then we process the MSB. So first what we do is LSB addition. What we're going to do is we are going to process this string bit by bit. So I'll write the string again here. This is a string given to us. I'll have a variable answer equal to 0. First I process this bit here and I do answer equal to answer plus 1. When I do answer is answer plus 1, answer becomes 0 plus 1, that is 1. Then I process this bit here. I do answer equal to answer plus 1, that is 1 plus 1, that is 2. After I increment answer, I check if the bit is 0. If the bit is 0, I immediately break out and print this answer, that is 2. In other words, I am going to process character by character in my binary string that is given. I don't care that it's reversed. Still I process character by character from left to right of the reverse binary string. That is what input we have been given. Then I do answer equal to answer plus 1. As soon as this character equal to 0, I immediately break out and I print my answer. Obviously answer is set to 0 here. So this is kind of the pseudo code to approach this problem. Now let's dry run it for another important case, that is when we have a string like this. You might say if you have a string like this, you don't even have a 0 here. So how does that work? Let's see. Now our answer is 0 here. Then we start processing. Then we process this bit here and answer becomes 1. Then we process this bit here and answer becomes 2. Now this condition is never going to be satisfied for this type of string because all the bits are 1. You're never going to encounter 0. So again you encounter this one here and you increment your answer to be 3. And then your whole string is over and you're going to print 3. Now this approach works for the main reason that also normally when you do 1 1 1 plus 1, what you get is basically 1 0 0 0. Basically if you do 7 plus 1 you get 8. But this question states us to ignore the additional bit that is encountered and output the difference in bits like this. So that's why the output is 3 because 3 bits have changed, and that's why this approach here is the correct approach. Hope this is clear. Now let's look at a few mistakes to avoid. Let's look at this first. Here what happens is we are taking the number of test cases input, and then for every test case we input the n as a string, which is a binary string in the reverse format that we have been given by Loki, and then we take the length of the string. Then we have answer equal to 0. Then we are processing character by character. We're checking if that character is 1, we increment the answer. As soon as we encounter a 0, we break. At first glance, you might think that this is correct. But you're forgetting that when we encounter a 0 also, first we need to increment the answer by 1 and then we need to break. So what is this? Let's say that the string that we have been given is 1 1 0. This is a reverse string. So the original string corresponding to this is basically 0 1 1, and then when you add 1, what you end up with is 0. Then 1 plus 1 is 0, and then you end up with this. This basically means that all 3 bits have basically changed. Since all 3 bits have changed, the answer should be 3 normally. But in this case, what we do is we process the 1 and we increment the answer to be answer equal to answer plus 1, and then that becomes 0 plus 1, that is 1. Then we encounter the second one here, and according to this condition, we do answer equal to answer plus 1, and now it becomes 1 plus 1, that is 2. Then as soon as we encounter a 0, we break out and then we print 2. But you know that the answer has to be 3. That is why just before breaking out, just include the fact that you need to increment answer and then break out. Hope this part is clear. Now let's look at this second code snippet that I've taken from the submission speech. What they're doing here is they're taking the string as input, and then for every character of the string, they're checking. As soon as you encounter a 0, they're incrementing the answer and breaking out. If the string character is 1, they increment it. This looks very similar to this here. Because what they're doing here is as soon as you encounter a 0, they're incrementing the count and breaking. Otherwise, when the encountered character is 1, they increment the count and they print the count. In fact, there is nothing wrong with this part of the code. The only thing that I missed out is taking the number of test cases input here. As soon as you take the number of test cases input, I think this whole code will work. Now, there is another mistake that we need to keep in mind in this problem especially is when you code it in Python, Remember to use a strip function while taking input, because if you even write the correct logic and you don't use a strip function, sometimes you might get a W here. So strip just removes the backspaces at the front and at the back of the string. That's all it does, and it helps when you're taking input. Let's first look at the C++ code. We take the number of test cases as input, and then for every test case we take the string as input. Then what we do is we find the length of the string, and then we iterate over all the characters of the string, and we check if the character's value is 1. Basically we do answer plus plus. Otherwise, if the character's value is 0, we first do answer plus plus and then break. As discussed, this is important. Before breaking out or encounter 0, we need to increment the answer. At the end, we just output the answer. The time complexity for this solution is O of length of the binary string, because for every test case all we're doing is iterating over the characters. As you see, you get an AC here. Now let's move on to the Python code that is very similar. In Python, what we do is we take the number of test cases as input, and then for every test case we take n as input. N denotes a binary string, and then we invoke the strip function also here. Then we have variable answer is 0, and then for every character in n we do answer equal to answer plus 1 first, and then we check if character equal to 0 and then break out. This is also another way of implementing the same logic. As we see, we get an AC in Python. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.